Okay, I'm making this recording to help out my friends, study mates who are also taking this class and might not have very good not lecture instruction, lab instruction for their project. So I have the benefit of taking Dr. Rango's class for lab, and she's really thorough with her explanations. This week we are doing chapter 12, and it coincides, it doesn't relate in any way to the chapter we're doing in science in lecture. We are, I think, on chapter 14 now in lecture, but this is chapter 12, and it honestly has nothing to do with lecture. So what you're going to do is, if you have the same lab, this is Biology 101 at Anne Arundel Community College, in your Canvas module, your professor may put it somewhere else. My professor put it under announcements. There were two files. I downloaded them. They were called Lab 12, let's see if it pops up. Lab 12, honey, I'm making a video. Lab 12 Predator and Lab, I can't see the full titles, but it's this document and this document. So I highlighted the portions that my professor highlighted, so that would be useful for you to know. I'm going to go over this in just a moment. Yes, can you save me some? Sorry, it's my children. So things that are important to remember is when you're doing this project, you're going to be reading through this information on this file and then filling in the chart on this file. On this file, if you notice, this represents each generation. This is 1 through 14 where you're recording data. On this chart, it goes through 15. You can't scroll over and see this, so I just drew it in on my own. I just kind of drew in some extra lines. What you are going to do, I highlighted this too. If you want to pick your own two colors to coordinate, this will end up coordinating with graphing down here. So, assumptions you're working under is that from each generation to generation, the number of surviving mice will double. So if at the end of generation 1, there are 5 mice, at the beginning of generation 2, there will be 10 mice. If you have 15 mice at the end of generation 2, at the start of generation 3, you will have 30 mice. So always assume that mice will double their population at the start of the next generation. The surviving, not the starting. So if you start out with 20, 5 get eaten, so you only have 15 left, you're not going to double from the original 20 and go to 40. You're going to double from the surviving mice. Another assumption is that if all the mice get eaten, just presume that 10 mice are going to migrate from somewhere else. So you're always going to have a minimum of 10 mice. So in each generation, at least 10 mice are initially present in the meadow. The meadow being your bowl with the M&Ms or the popcorn kernels or whatever it is that you're using. The maximum number of mice that the meadow can support is 100. So if you have 60 mice at the end of a generation and you double it and you would normally have 120, do not put 120. The max is 100 because the meadow can only support 100 mice. In each generation, at least one weasel is present. So if there are not enough mice to support the survival of all the weasels, just assume another weasel from a nearby meadow is going to come into the meadow to try to eat the mice that are there. So even if no weasels survive at the end of the previous generation, you will at least have one weasel present. In order for a weasel to survive in your meadow, in the meadow that's the bowl with your M&Ms or popcorn or whatever, it must capture at least 5 mice. So if you capture 4 mice, it doesn't survive and it doesn't have offspring. If it captures 5 to 9 mice, it will survive and it can make 1 offspring. That's addressed in number 6. So for each 5 mice that a weasel captures, it will produce 1 offspring. So if one weasel captures 17 mice, it survives and it can produce 3 offspring. There'll be 2 extra mice that it got to enjoy, but it does not help it produce another offspring. So that data is, those assumptions will help you when you are going over this. This experiment or procedure, they give you 4 generations. They walk you through 4 generations to start, and then after that, that is when you start doing your own procedure with a spoon, going through the diameter of your bowl with popcorn kernels or M&Ms or whatever you choose. So to start, you're going to put 10 mice and 1 weasel in the meadow. So put 10, like in my case, I'm going to use mini M&Ms. I'm going to put 10 mini M&Ms in the bowl, and I'm going to use a little spoon so I don't kill out my population really easily. I have a child spoon from when my kids were little, and the spoon represents the weasel. So let's see. You enter the data in here. So let me switch to, I'm going to see if I can pause it so I can switch. So in the first generation, it says you're going to begin with 10 mice and 1 weasel. And it says the weasel in this first generation does not capture any mice. So right here under generation 1, begin with 10, you have 1 weasel. The capture of mice is simulated by the scooping of the spoon once through the dish, and it says elsewhere through the diameter of the dish, so through the center. You're not trying to scoop up all the M&Ms, you're just going through once through the diameter. However, we assume that in the first generation, the weasel does not capture any mice. So you're going to enter, so initial prey, that is the mice or the M&Ms, so you have 10 to start. To see if I can move that over. And then the initial predators is 1 weasel. They said it captures 0 mice. So over here, this is where you put how many it captures and how many offspring each predator gets, because you're eventually going to end up with more predators than just 1. So here you enter 0 mice captured and 0 offspring. Over here, you have the initial prey is 10. The total prey captured was 0. The prey survivors, well, since no mice were captured, you have 10 mice that survived. Predator survivors. So if you recall, if you're wondering how many of the predators survived, it needs at least 5 mice in order to survive. That's under the assumptions. So you go up here to the assumptions. In order for a weasel to survive in the meadow, it must capture at least 5 mice. So it did not capture any, so the surviving predators is 0. And then additionally, for each 5 mice that a weasel captures, it will produce 1 offspring. It didn't capture any, so it has 0 offspring. Now, we had 10 surviving prey, which are the mice. Every generation, it doubles. That is going under the assumption here. The surviving mice of a generation always double their numbers. So here, you have 10 prey survivors, so that is going to double and be 20. I wish I could move this more easily, but let me see. Never mind. I'm just going to undo. Okay, so now we have 20 mice. Let's go to, we're in the second generation. Let's see what happens in the second generation. In the second generation, as there were no predator survivors or offspring, we will assume that another weasel immigrates into the meadow. So, initial predators. I need to shorten this so it's not, there we go. Initial predators is 1. And then let's see how many mice they capture. Assume another weasel immigrates, scoop through the dish, picking up 4 beads or 4 M&Ms or kernels. So in table 1, enter 4 for prey captured by predator 1 of the second generation and 0 for predator offspring. The reason why 0 is because they only captured 4 prey. They need 5 to produce offspring. So in this second generation, the predator captured 4 mice and produced 0 offspring. So over here, you're going to write, I'm going to have to shorten this so it doesn't try to enter in there. So total prey captured is 4 mice. The total prey that survived is 20 minus 4, so it's 16. And then the initial predator was 1. Did it survive? How many surviving predators are there? Well, did it capture 5 mice? It didn't, so it didn't survive. There are 0 surviving predators. Move this over here. And then offspring, it didn't eat enough mice to produce an offspring, so it's 0. So to determine the starting number of mice, you're going to look at the prey survivors. It's 16, so it's going to double. Sorry, I have to shrink this. Okay, so 16 times 2 because it doubles every generation. Sorry, I'm going to pause this while I adjust it. So the total number of mice population has doubled. Let's see in this third gen, and as far as number of predators to start, the initial predators, there were 0 surviving predators and there were 0 offspring, but you don't put 0, just there's always the assumption that 1 is coming from another nearby meadow. Shrink that. Now we are in the third generation, so let's see what happens. So again, assume that another weasel immigrates into the meadow. Scoop once through the dish, this time picking up 7 beads. In table 1, enter 7 for prey captured. Also enter 1 for the offspring produced. My kids need me, so I'm going to pause. Sorry about that. So we are on the third generation. I think they said 7 gets scooped up. Yep, so 7 mice. So under the captured, you have 7 mice captured. Under offspring, if you recall, based on the assumption, under here, for each 5 mice that a weasel captures, it will produce 1 offspring. So it can produce 1. If it had 10 to 14, it could produce 2. So over here, the total mice captured was 7, so we're going to put 7 into this box. 32 minus 7 is 25 remaining or surviving mice. The weasel survives, so there's 1 weasel that survives, and it has 1 offspring. Get that shortened down. So to determine the starting generation of mice for the 4th generation, you take the surviving prey and double it, which makes it 50. And the initial predators is going to be the combination of the surviving predators and their offspring. So we have 2 surviving offspring. Now let's see what happens in the fourth generation. This is the last generation that they give us before we start doing it ourselves. So in the fourth generation, it says there are 2 predators in generation 4. Let's see, add predator survivors. And that's another thing so whenever we put this total, I forgot to clarify, in your bowl, you're not doing it during this because this is all simulated, but once you get to the 5th generation, you will add the total number of mice, mice or the beads or M&Ms to start, and then you take out whatever gets scooped out by the predator. Those get removed and put into a separate bowl, and then when it doubles, going to the next generation, you have to put in that many more M&Ms to make sure that population is present. But let's finish the 4th generation. So it says, so table 1, scoop once through the dish, picking up 13 beads or 13 mice. So in table 1, 13 mice are captured, and that means they can produce 2 offspring because they need one. They can do 1 offspring for every 5 mice captured. So 13 mice are captured by the first predator, and they produce 2 offspring. I'm going to scoot this over because now this is going to be a little different because there's a second predator. This is the number of predators. There's a second predator. This predator, scoop once through the dish and pick up 7 beads, so 7 mice. The second predator gets 7 mice. Sorry about this. And it can produce 1 offspring. So over here, the total prey captured total is 13 plus 7. So 20 prey are captured. The prey survivors is 50 minus 20, which is 30. So there are 30 surviving mice after the weasels captured their collective 20. Those initial 2 predators survive. And they're able to produce 2 and 1 offspring. So there's 3 additional offspring total. So now you determine the starting population of mice. The starting population of mice is 30 doubled, so that's going to be 60. And then the initial predators that survive is a combination of the surviving predators and their offspring. So you have 2 surviving predators and 3 offspring that they produce, which is 5 predators to start. And then this is where you begin doing your own experimentation. So you would put 60 M&Ms or 60 popcorn kernels, beads, whatever it is that you're using, into your bowl. And then you would, for each predator, so you have 5 predators. So for each predator, you would scoop through. So you would scoop through once, pour those beads or those M&Ms into a bowl and count how many. So if you get 5, you're going to put over here 5 mice captured. That means it can produce 1 offspring. And you're going to do that for every predator. So you're going to have 1, 2, 3, 4, 5 of these filled out because we have 5 predators. Then you will add up the total prey captured, put that total here. you'll subtract 60 minus the total prey captured and put the number of survivors. You'll take that initial 5, determine if they each captured enough mice to survive. If they each captured 5 mice, then they do survive, and then calculate how many offspring they produce. It's one weasel offspring for every 5 mice they capture. So you'll write the 5 surviving predators if they all survive, all their offspring, then you add up those totals, put them here. You take the prey that survived, double it, and put it here. So whatever number you have here that survived, you're going to take that number of M&Ms or popcorn kernels and add it to your bowl so that you have that number to scoop from. I hope that helps. Let me know if you have any questions. Just text me or message me on Facebook if you're friends with me, and if not, just post below. Now moving on to the graphing portion of the assignment, if you notice, we have the initial prey in blue and the initial predators in pink. You can choose whatever 2 colors you want. I'm going to pause it while I get my tool set. So on my Adobe function, I use a highlighter, but I have to change the highlighted color after I add it. So down here, this is the number for both the mice and the predators. But you graph it in 2 different colors. So for the mice, in the first generation, you had 10 to start. So you'd put 10 here. If I can get this highlighter to work. Maybe if I do that. Going to pause it while I edit the color. All right, I don't know how my professor made such nice little dots, but that dot is supposed to be right at the cross where the 10 crosses this line, so it'd be right there. The next one, we start with 20 mice, so you're going to put a dot here. Just gonna, oh dear, I have to change it every time. Okay, my computer's battery is getting low, so I want to finish this quickly. So the initial prey are 10, 20, 32, 50, then 60. And that's for the 1st through 5th generation. So we have 10, 20, 32, 50, and 60. This comes down to, you can't see it very well, but it's the 5th generation. The initial predators is 1, 1, 1, 2, and 5. So you have 1, 1, 1, 2, and it jumps up to 5. These numbers are going to eventually come down as the prey run out, and then when the prey run out, the predators are going to run out of food supply as well. The last thing my professor told me is that in this column you won't have prey captured survivors or whatever, or prey captured, prey survivors, and so on. You're just going to have the initial prey and the initial predators for this last column.